Great day learners. In this video, we are going to solve 9709 paper 6, which is probability and statistics 2. We are going to solve the Indian zone 4 component we are going to solve, which is 6-2. And the model paper which you are going to solve is 2024 Feb March 1. And as you are aware, the duration of this component is 1 hour 15 minutes and then the maximum mark is 50 marks. You are allowed to use calculator and you'll be able to use the MF19 as well. Without any delay, let's start solving the problem. So the first question, if you see, the length x centimeter of a sample of 100 insects of a certain type were summarized as follows. So n equals 100, summation x equals 36.8 and summation x square equals 17.34. So here we have to calculate the unbiased estimates of the population mean and then variance. So it is simple, as we are aware that the formula for x bar is summation x by n. So accordingly, if you see, the given value is 36.8 divided by 100. So the x bar value what we are getting here is 0.368. So we find the population mean. Then next we have to find the population variance, which is a square. Let me write the formula once. 1 divided by n minus 1 into summation x square minus summation x the whole square by n. This is the formula and we will have to substitute the value. Just make a note that if you are just writing the formula, you will not gain any mark. But if you are substituting the value in the right formula, you will get the method mark. So 1 by n minus 1 is going to be 99 and summation x square is that 17.34 minus 36.8 square divided by 100. And the calculator gives us the answer as 0.0384. The only thing what you want to do is you have to put this entirely in the calculator, and whatever the calculator gives, that is the answer. Then the second subdivision is state a necessary condition for the estimates found in part A to be reliable. If you see here, the n value is already greater than 100 and they actually asked us to find that unbiased estimate of the population mean, so we don't need to worry about that what distribution or kind of thing. But here what we have to think is it should be a random sample, because whenever we want that reliable one, it should be a random one. So it should be a random sample. Right? So that's it, and this is enough for that 1 mark, and this is what the expected one. Let's move on to the next problem. It is a second one. A random sample of 250 people living in a parapet was chosen. It was found that 78 of these people owned BTEC phone, BETC phone. Calculate a 90 of approximate 98% confidence interval for the proportion of people living in Parapet who own a BTEC phone. So how we have to do? It is quite simple, because just the formula we are going to follow. What is the formula is? The formula is, it is x bar. It is not x bar, actually it is ps. The reason is it's a proportion is what given here. So we should use this ps plus or minus z multiplied by root of psqs by n. So this is what the formula that we want to write it, and if you see here, PS is 78 out of 250 people, and the answer what we are getting is 0.312. So if P is this value, then we can easily calculate what is a Q, that is 1 minus P. So 1 minus 0.312, which is nothing but 0.688. Okay, now, so whatever the things that we needed, that we have it, n is 250 here, that we know, but the z value is going to be what? You have to understand that if 98% is the confidence interval, so it is only in the mid. So left side 1%, as the left side 1% and then right side 1% will go. the middle part is going to be 98%, but Z value is not going to say about 98. It is going to say where we are going to give the marker, this final marker. It is actually calculated from the beginning. So if you see here 1%, here 98%, so Z value should be there for 99%. So you should be mindful about calculating what is its Z value. You are not supposed to take directly what is the confidence interval percentage is given. So 99% in the sense the respective Z value is 2.326, that you have to get it from the Z table. So that's it. We just have to substitute the values in the given one. So according to this formula, the PS value is 0.312 plus or minus 2.326 root of 0.312 multiplied by 0.688 whole divided by 250, which is the given n value. And when we are calculating, when you're subtracting, you will get the lower limit, and when you're adding it, you will get the upper limit. The lower limit calculated value, what I'm getting here is 0.244. So less than or equal to PS, less than or equal to the maximum value, what I'm getting is 0.380. It's a rounded value for the three significant figure. You can also write the PS will vary from, the proportion will vary from 0.244 to 0.38. Anything is fine. Let's move on to the next one, the B subdivision. Manjit claims that more than 40% of the people living in Barapet own a Betek phone. Use your answer to part A to comment on this claim. Manjit is claiming 40% of the people living in Barapet own a Betek phone. But if you see here, the confidence interval is only for 24% to 38%. So that itself we can write as a reason. 40% is outside the confidence interval. Because the confidence interval, maybe if you want, you can write it confidence interval is from 24.4% to 38%, because that's what we got it here, right? So what are we going to conclude this? Manjit's claim is not true. So just we have to make the decision according to the calculation that what we got it. Let's move on to the next one, the third problem. In a certain lottery, an average one in every 10,000 tickets is prize winning ticket. An agent sells 6,000 tickets. So we can see that it is actually a binomial one in 10,000. The p value is 1 by 10,000. But they told us to use that approximating distribution to calculate the probability of at least 3, means probability of x greater than or equal to 3 we will have to calculate. So since the p value is this, we have to go for the approximation distribution. So the approximating distribution, if we have to go, the lambda value is going to be why lambda? Because from binomial, when we are approximating, it actually goes to Poisson with the parameter lambda. So but in the AS level, we used to work out the normal distribution, but here from binomial to Poisson is what going. So if you have to calculate lambda, we are aware that it is a mean, so it is n into p. N is 6,000. So 6,000 multiplied by 1 by 10,000 will give us the answer, which is 0.6 is the lambda value. And we have to calculate probability of x greater than or equal to 3. So instead we will find 1 minus probability of 0, 1 and 2. So 1 minus probability of 0, it is going to be so usually if it's Poisson distribution, we will put e power minus 0.6, we will put it, and 1 plus 0.6 plus 0.6 square by 2. This is what the Poisson distribution formula, and if the calculated value gives us the answer 0.0231. If you want, I'm just writing the probability of x for um, Poisson distribution is e power negative lambda into lambda power x by x factorial is what the formula. This is for 1. For 0, or if you're finding for many things, it is going to be like e power minus lambda can be taken out, 1 plus lambda power 2 by 2 factorial plus lambda power 3 by 3 factorial. It continues. Since we want till 2, so I'm doing this and I got the answer. And when you're moving on to the next one, justify the use of your approximating distribution. From the binomial to the Poisson, when we are going, we have to check n should be, n is actually 6000 here, but actually if it is more than 50, that is enough. So the second thing is np is here we are getting 0.6, but if it is less than 5, that is enough. Therefore the approximation is valid, or approximating distribution is valid. So maybe the same conditions what we followed for AS level normal distribution, the same condition is what there for Poisson distribution as well. We are going to solve the fourth problem. Each year a transport firm uses X liter of gasoline and Y liters of diesel fuel, where X and Y have the independent distribution of X is with the mean 10,700 and variance as 950 square. And for diesel, the mean is 13,400 and then variance is 1210 square. Find the probability that in a randomly chosen year the firm uses more gasoline than diesel fuel. It means that they are using more gasoline than diesel, so x greater than y. X greater than y, how can we write it? Actually, the first work what we have to do is we should write as a proper inequality or equation. So it's going to be x minus y is greater than 0. This is what the mathematical one, because variable one side and then constant another side. Then now we will get to know that what is the thing that we will have to use it for mean and standard deviation. For mean, it is mu is equals, so what we have to do, x minus y. So x minus y in the sense 10,700 minus 13,400. So that value what we are getting for mean is minus 2,700 we are getting. And for sigma square what we are getting is the existing one 950 square. Maybe you can ask why we are not multiplying by the number, because that number is 1x 1y, so 1 square. Maybe that is not going to make a big deal. And minus, though it is minus for variance, we will use plus, and 1210 square. So the value what I'm getting is 236600 is what variance is. And now the value is 0, so pi of 0 minus mean, which is minus 2700, whole divided by root of 236600. So now the value what I'm getting is pi of negative 1.755. So for this, if you're getting negative, what we should do, we should find the positive and we should subtract it from 1. So the answer what I'm getting is 0.0397 as the final one. If you see, the working is very less, but still this finding mean and standard deviation actually takes a little bit more mark. That's why actually they are providing you 5 marks. If you want the formula, it's actually quite simple. X minus mu divided by sigma is what the formula that we use it, and that's what I did. I just have substituted the value. X is the value which is here, mu is the one what we found it here, and then the sigma square is this. So I'm just taking the root and then I'm applying it in the problem. So just applying it in the formula takes actually 3-4 steps, and it is going to give us mark. So one work is converting the given statement to a mathematical notation, and then second one is finding mean and then the variance. That is going to give us 5 marks. Let us move on to the next subdivision. The cost per liter of a gasoline and diesel fuel are 80 cents and then 85 cents respectively. Find the probability that the total cost of gasoline and diesel fuel in a randomly chosen year is between 20,000 to 22,000. So we will have to find between 20,000 to 22,000. So before that we will have to calculate the mean and standard deviation, right? So when we are going to find out the mean and standard deviation, it is actually total of this. So we may think that we don't want to square for variance, but okay, let's do mean first. Since we have to find out x plus y, it is not directly x plus y, it is the cost of x plus y. First thing what we have to do is for mean, uh, there are how many actually liters. It is the mean cost is 10,700, and it is cost, it is not total gasoline, it is just cost in the sense 10,700 multiplied by 0.8 plus uh, 13,400 is the cost of diesel multiplied by 0.85. So the mean what I'm getting is 19,950 I'm getting. Next we will have to find out the variance. So here we, for variance, what we have to do, the existing variance we should multiply by either 0.8 or 0.8 square. If you are saying it's a quantity 4 liters of diesel or 4 liters of gasoline, in the sense we just want to use only 0.8, but it is actually cost, it is unique value, it differs, it's not having the similarity, so we will have to use 0.8 square plus 1210 square multiplying by 0.85 square. So this gives me the answer as 1635412.25 as the sigma square variance value. Now I just want to execute the probability. That is also an easy thing. So this is what takes time and a more knowledge required. Then after that it is quite simple, because we want to find out between 20,000 to 22,000. Right? So now what I should do, I should find for how actually we approach this type of problem, the upper limit value. So pi of 22,000, that probability minus mean value what we have calculated is 19950 whole divided by root of the standard, standard deviation, so it is root of variance 1635412.25. So for upper limit we should find first, then for lower limit we should subtract it. So pi of 20,000 minus 19,950 by root of 1635412.25. If you see, you can feel that we are just repeating the work, or we are just applying it in the form of this formula. We are actually using it from the maybe the second problem onwards, third problem onwards. So it's a quite simple, the regular work what we have to do. But though it is A level, the difficult level, why are they giving us the 5 mark? It is just because you should have this idea. Only then you'll be able to gain the further marks. So that's why. So the calculated value of this I'm getting as 1.603 minus pi of 0.039. So the respective probabilities are 0.9455 minus 0.5156. When I'm subtracting, I'm getting the answer as 0.4299. But I will have to give the answer as the 3 significant figure. So it is going to be 0.430, because that answer is 3 significant figure, right? It's quite simple. Actually, if you see from here, it is very easy one, but here is what actually they are expecting, that how brilliant are you. If you know this, then your 5 mark is in your hand. Now we are going to solve the fifth problem, and this is the universal problem, I guess, because a teacher models the number of girls and then boys who arrive late for a class on any day by the independent random variables, girls with a Poisson distribution of lambda 0.1 and boys with 0.15 as the parameter. So a teacher models that who arrive late for the class. Find the probability that during a randomly chosen 2-day period, no girls arrive late. So no girls arrive late is what we will have to calculate. It means that, but it is a 2-day period, so the lambda value is going to be 0.1 multiplied by 2, which is 0.2. Since we have to find the probability of 0, so the value is just e power minus lambda. So e power negative 0.2 is the value, that is 0.819. Yeah, right. So it's easy. So let's move on to the next one. Find the probability that during a randomly chosen 5-day period, the total number of students who arrive late is less than 3, but it is, they mentioned a student, they did not mention that uh, boy or a girl. Student in the sense it covers both boys and girls, so that we will have to find the total boys and girls, so that lambda is going to be 0.1 plus 0.15, which is 0.25, but that is for 1 day. Since they have given that for 5 day, we have to multiply this value by 5, so lambda value we are getting is 1.25. Now we want to find out the number of students who arrive late is less than 3. It means x less than 3 we have to find. Less than 3 in the sense that is nothing but 0, 1 and 2 we have to find. So whenever that combination of the Poisson it comes, we will have to do e power minus lambda, 1 plus lambda square by 2 plus lambda cube by 3 factorial, and keeps going, is what we had to do. And here if you work out, when we are applying the values here, e power negative 1.25 into 1 plus 1.25 plus 1.25 square by 2 factorial, or 2, and the calculator value is 0.868 I'm getting, and that's it. Even here the concept what you want to understand is this one lambda, and after that what is the formula and how to apply in it. That's it. The calculator will give you the 3 marks if you are doing all this together. So the next one is actually, it's quite interesting and a new kind of problem. It is given that the values of P of G equals R and the probability of B equals R. For R greater than 3 are very small and can be ignored. So okay, let's proceed reading. Find the probability that on a randomly chosen day more girls arrive late than boys. So girls arrive late than boys is what we have to find it. Maybe if you see it is on any day, maybe out of 5 days girls can be, I mean 3 days, and boys can be 2 days. They did not give us anything like that how many days it is, but they gave us one thing, that R cannot be 3. It is R is actually stands for the days. So R for greater than 3 and above, it is very small and can be ignored, in the sense we no need to find for 3 and above. So we have to find only for 0 to till 2 we have to find it. So from 0 to till 2, when girls are going to be late than boys. So if you see girls and boys, we can list out boys maybe 0 days, and the sense girls can be late for 1 day because that is also bigger. And if boys are late for still 0, girls can be still 2, because till 3, I mean till 3 it is allowed, so we can go up to 2. Then when boys are 1 day late, then girls can be late for 2, and beyond that it is not possible because it will reach 3. So this is what the combination 1 and 0, 2 and 0, 2 and 1 is what we will have to calculate. So that is what actually they are asking. Find the probability that on a randomly chosen day more girls arrive late than boys. So now let's do this. We want the combinations, we did it already. So for that combination, if the girls, it is just for 1 day we are calculating, because 1 day 2 days, that accordingly we will have to do. And the same lambda values what is given here is what we are going to take it, because that is for 1 day thing, because for any day. So now if you see 1 and 0 means girls 1 day and boys 0 day. So girls 1 day in the sense negative 0.1 multiplied by 0.1. This is for 1 day girls. For boys it is negative 1.5. That's it, because it is 0. So this is one possibility. The second one is 2 girls and 0 boys. When girls are 2, it is e power negative 0.1 multiplied by, it is just exactly 2 days. It is not 0, 1, 2 like that. It is exactly 2 days. So it means that 0.1 square by 2 factorial, and by still remain as 0. So it is e power negative 1.5. Then plus by, I mean, girls 2 days and boys 1 day. So for girls, if it is 2 days, we already did e power 0.1. 0.1 square by 2 factorial is for girls. For boys, it is 1 day. 1 day in the sense e power negative 1.5 multiplied by 1.5 is what we will have to do. So this is the first combination. Here is the second combination. Here is the third combination. That entire value, if you put in the calculator, we are getting the answer as 0.0824 for rounding up to 3 significant figure. If you see, this question is quite new thing. It is interesting one. Maybe you may also find it hard, but if you understand the essence, it is nothing easy. So the next subdivision is actually testing, hypothesis testing, and it is interesting one. Okay, let us read the problem. Following a timetable change, the teacher claims that on average most students arrive late than before the change. So after the timetable change, she is realizing that more students arrive late than before. So during a randomly chosen 5-day period, a total of 4 students are late. In the 5 days, 4 students are late. So test the teacher's claim at the 5% significance level. What is the usual process of testing it? It is, as I mentioned, the first one is hypothesis is the first thing that we have to do. So what is a hypothesis? It is null hypothesis, which is here, since it is related with Poisson distribution, lambda value is 1.25. How it is 1.25? It is because for 1 day, uh, it is actually, we have calculated for a 5-day period already that lambda equal to 1.25. That is what we are going to take it. And the teacher claims that the new one is actually increase, so we want to take it lambda is greater than 1.25. This is what the hypothesis. In the hypothesis, we will give null hypothesis and alternate. In the then we will have to go for testing. How to test it? Since we are checking whether it is increased, we have to find probability of x greater than or equal to what is the value, that given value is tested value is 4. This is what we want to check. So how to check probability of x greater than or equal to 4 in the Poisson distribution? So usually we do 1 minus probability of 0, 1, 2, 3. Just applying the regular formula, 1 minus e power negative 1.25, 1 plus 1.25 plus 1.25 square by 2 factorial plus 1.25 power 3 by 3 factorial. So these calculated values are giving me the answer 0.0383. If you ask me testing, actually testing is over now. Now we are going to the conclusion. So the conclusion is we are getting the probability of 0.0383, and we should compare this with 5%, that significance level. 5% is nothing but 0.05. The value is lesser. When the value is lesser, the test is passed. It means that new claim is true. So we can say that there is enough evidence. For what? There is enough evidence for what? On teacher's claim, the new claim, that more students are late than before. So this is how the testing works. So whenever the hypothesis testing is there, we will be doing three different things, which is hypothesis, testing, and then conclusion. In the hypothesis, we have to give what is the existing value and then what is the claim. Then we have to do the testing with the given values. Then after the testing, in the conclusion, we should compare the probability value with the significance percentage. If it is lesser, we will say there is enough evidence. It means that new claim we will take it. If it is greater, we will say that the old claim is true. Right? We are moving on to the next problem, which is sixth one. The graph of the probability density function f of a random variable x is symmetrical about the line x equals 2. So the curve is symmetrical about x equal to 2, and then the given probability is from 2 to 5. Maybe let us take till this. The probability is given as 117 by 256. Using only this information, show that probability of x greater than minus 1, negative 1 is 245.256. So negative 1 is the limit that we are taking. If you see here 3 units, so here also 3 units, so both are equal. It means that the right side probability is 117 by 256, the left side is also 117 by 256. But we know the entire left side, because the 2 is the mean, so the entire value is going to be 0.5. If the entire value is 0.5, and then this probability from minus 1 to 2 alone, 117 by 256 if we realize. So the remaining probability we are getting as 111 by 256. So this value alone 11 by 256, but they are asking greater than that. They don't want less than that, greater than that. So the probability of x greater than negative 1 is 1 minus the value what we got there, which is 11 by 256. So the answer we are getting is 245 by 256. That is what we want to prove it. So the answer is given, we just want to prove it. If you take any idea, maybe any kind of understanding thing, you will be able to solve this, but the method is maybe going to be different. The right side, left side probabilities are same. With that, I'm just comparing off probability and I'm getting the left side, the one what I want what I'm getting, and the one what I want I'm subtracting from 1. Okay, next one, it is now given that for x in a suitable domain, f of x equals k into 12 plus 4x minus x square, where k is a constant. Find the value of k. So actually we don't know what is the domain of this function, right? But they mentioned x in a suitable domain is what they mentioned. What is the thing that we know is whatever it is, the given probability for 2 to 5, maybe this can be used, this can be, anything can be used. So 2 to 5, the given itself, we will take it y risk. So from 2 to 5, if you are finding the probability for the given function, it is going to be the 117 by 256. That's what they said. It is 117 by 256. So now if you integrate these things and then we get it, we will get to know the value of k. When we are integrating 12, it is going to be 12x. When you are integrating 4x, it is 4x square by 2, that is 2x square minus x square if you are integrating x cube by 3. And then the upper limit is 5 and then lower limit is 2. The k is still here, and that is equal to 117 by 256. Now we will have to apply the upper limit. When I'm applying the upper limit, 12 into 5, 2 into 5 square minus 5 cube by 1 by 3, I am getting the upper limit as 205 by 3. Minus, in the same way, if I'm applying that lower limit, I'm getting the value as 88 by 3. That is equal to 117 by 256. So this answer is giving me the value of 39. So 39k is 117 by 256, and k is that 117 by 256 whole divided by 39. In any means you can do it. So that value of k is 3 divided by 256. That's it. We found the value. We'll move on to the next subdivision, which is a different random variable x has a probability density function. It is a different function, g of x equals this one. The domain of x is all values of x for which greater than 0. So maybe this one also a quite complicated one. Why? Because the further calculations when I'm doing, you will not feel it is hard, but still understanding the given one from the starting point, the kick starting point is actually a difficult one. That's what I feel. The domain of x is all values of x for which g of x is above 0. So g of x is its output. They are saying output is greater than 0. That is what the domain is. So the domain of the function is when the y is greater than or equal to 0. So for example, since it's a quadratic, let's take the values at upper hand. It means that the above 0 means we should find where it is intersecting the x-axis, the root. Then above that we will have to take it. So the function 2 by 9 can be ignored. So 2 plus x minus x square is equal to 0. If you are solving this, the two factors what we are getting is x equal to -1 and 2. So when you are solving this you can use, actually you will have to show the step that is better. You can also like do any method whatever you like it. I'm just doing the factorization method and I'm getting that answer as this can be factorized as 2 minus x into 1x plus 1. So the two factors are x equal to -1 and 2. It means that the curve is intersecting the x-axis at -1 and 2. In the rest of the place it's going down. How can you say like this? And if you ask me, because it's a quadratic parabola. So the parabola, in the sense it intersects the x-axis and it is open downward, it's just because it is negative x square. So -1 to 2 is the domain. So -1 to 2 is the domain for the function, and we want to find out the variance. If you want to find out the variance, we should have two things. One is x square f of x, it is g of x here, that we should find it, and we should subtract it with mean. What is the mean here? As it is parabola, so the mean will be the vertex. What is the vertex? -1 to 2, the vertex is going to be midpoint of this, which is 0.5. So e of x is 0.5. So I should find x square g of x dx. So what is that? It is 2 by 9, the given function, integral over -1 to 2. 2 plus, actually I should multiply by x square, sorry, x square should get multiplied by 2 plus x minus x square, the given function, into dx. When I'm multiplying, I'm getting 2x square plus x cube minus x power 4. This is what I will have to integrate it with the limits as -1 to 2 and 2 by 9 is the constant that I have. Then 2 by 9, when I'm integrating, I'm getting 2x cubed by 3 plus x power 4 by 4 minus x power 5 by 5. I'm sure that you people are very good at this because this is just integration thing. You are doing it for the past 2 years. Then when we are applying the upper limit, we are getting 44 divided by 15 as the value, and the lower limit gives us -13 by 60. Since the one negative will come, it makes this as positive, and then the simplified answer I'm getting is 0.7. So in this we will have to apply it. So if I'm applying, it is 0.7 minus the mean what we have got is 0.5 square. You know that, right? Sorry, I just wrote e of x wrong. It is e of x square. So 0.5 square, if you subtract that answer, what I'm getting is 0.45. So that is what the variance is. And 5 marks, if you see the normal integration stuff, finding mid value as e of x, they all will be easy, but you just have to understand this. The domain of x is always all values of x when x is, I mean, g of x is greater than or equal to 0. That matters here. We are going to solve the last problem of this paper. The heights in centimeters of adult female in Lithuania have mean mu and standard deviation sigma. It is known that in 2004 the values of mu and sigma were 163.21 and then variance is 6.95 respectively. The government claims that the value of mu this year is greater than it was in 2004. In order to test this claim, a researcher plans to carry out a hypothesis test at the 1% significance level. He records the heights of a random sample of 300 adult females in Lithuania this year and finds the value of the sample mean. State the probability of a type 1 error. So the type 1 error, you can see that there is no calculation is given, so that how can we find it? Still we can do it because the significance level is what the probability of type 1 error is going to be. So probability of type 1 error is 0.01. Right, so let's go to the next subdivision. You should assume that the value of sigma after 2004 remains 6.95. Given that the value of mu of this year is actually 164.91, if they are giving the actual value, it means that they are asking probability of type 2 error. Yes, that's what they are asking, and we want to find it. As I mentioned in the last paper, the probability of type 2 error has two parts. One is finding critical region and another one is type 2 error's probability. That is what we will do even for a probability of type 1 error as well. So when we are doing this, what we have to do, first thing we have to find out the critical region. So the critical region is what we have to find at first. So the probability of what actually they are saying that it is increased. So here they set the 1% significance level. So probability of x greater than a is 0.01. That is what x greater than a is 0.01. But 0.01 we won't be able to use it. Usually the probability minimum 0.5 or above, so we have to convert it, so it is becoming 0.99. so on the right side, if you are making the conversion, the left side also we will have to make the conversion, which is probability of x less than a. So this one we can use it instead of this because that's what we can use it. So probability of x less than a is 0.99 is for the critical region, and we need to find out what value gives the 0.99 as the probability. So how to do? Pi of the value we don't know, so a minus mean is 163.21. the old value we will have to use it when we are finding the critical region. Just keep it in your mind, divided by how many people they have tested. 300 adults they have tested. So before that, sigma value remains 6.95 divided by root n, root of 300. Why that root n is coming here additionally? Because this is uh, actually a sample one, so that we should use that value is equals 0.99. Then the pi goes that side, it is going to be pi inverse of 0.99, and we know that pi inverse of 0.99 is 2.326. and here how that values are going to be, a minus 163.21 divided by 6.95 divided by root of 300 gives this answer. And let us move this value to that side, which is 2.326 multiplied by 6.95 by root of 300. Then we'll move this one also to that side, the negative goes that side, it is positive 163.21. so the a value what I'm getting after the calculation is 164.14 I'm getting. So I got the critical region value. Now what all I want to do is I want to find out the probability of type 2 error. So how to find out the probability of type 2 error? Probability of type 2 error is nothing but 1 minus critical region. What is critical region? The x greater than a is critical region. If x greater than a is critical region, so its opposite is what? Type 2. So I just want to find out probability of x less than a, but the a value we got it in the previous step. That's what the work we did before. So 164.14. we want to find out this. So when we are doing this, we are supposed to use the actual mean which is given. That we have to apply only when we are finding the probability. So it is normal, so simply 164.14 minus 164.91 divided by 6.95 divided by the same 300 samples. If I'm doing, I'm getting the value as pi of negative 1.918. this is giving me, actually I should do 1 now, 1 minus pi of positive 1.918, and that the answer what I'm getting is 0.0276 is the value that I'm getting. And here uh, I should actually keep two things in my mind, which is whenever I'm finding the type 2 error, two things I will have to do. The one is the critical region and then type 2 error. The critical region, whatever is given, if the value is increased in the sense probability of x greater than a, if the value is less than and x less than a, we should use. But here they gave it as greater than, so I'm just using it and I'm getting the critical region value. After getting that what value gives that particular confidence interval, I mean the significance level, then I should find the probability of type 2 error. This is the reverse of it. Since there the critical region is probability of x greater than a, here I should do 1 minus that, or probability of x less than a. The value of a I calculated before, and then the mean I should use it. The actual mean I should use it for the calculation, and then the probability what I'm getting is 0.0276. Thanks for watching this video. This video has completed all the problems that are worked. If you have any comment about the video, please do comment in the comment section, and if you have any suggestion for the next video, please do ping me. And also, if you are feeling that some of the problems are difficult problem which you are finding it harder wants to be solved, just send me the code. I mean the code in the sense the year, the problem, the component number, the problem number, everything. If you tell me, then I can work and send you. Or you can even send me as a, like, how to say, you can send me the problem to me so that I can actually work out that, and I can post it as a video, or else I can even give that as a reel, so you will be getting benefited. So subscribe my channel if you are watching it, and if you haven't, subscribe and share it with your friends who is studying A-level mathematics, so it will be helpful for them. And if you want to follow me in the Instagram, you can actually follow me in this ID, adolph.sathish. In this ID you can follow, and in this you can actually give me a DM that whatever the problems that you want to send me, that you can send it here, so I will take it from there and I will give you the solution in the YouTube channel, so that you will also get benefited. Share this video with the person who needs. Thanks for watching.